Hello, in this session I'm going to continue talking about triangles. In the last session I've talked about Pythagoras theorem. I'm going to say a little bit more about that. A squared plus b squared equals to c squared. It is a theorem, an equation about a right-angled triangle. A triangle with one of the sides 90 degrees. So it is a formula that tells you how to find the longest side if you know the two shorter sides. Right? Now, let's look at an example. Now in the last session, I've used this example and found that the answer to the longest side is 5. Right? That means that if I put the numbers in the equations, I have 3 squared plus 4 squared is equal to 5 squared. Right? If you calculate the left side, it will be equal to the right side. Now there is something special about these 3 numbers in that they are all whole numbers, and you don't get that very much at all. Most of the time, if you have, instead of 3 and 4, you have other numbers like 3 and 5 or 5 and 6 and so on, you will not get a whole number for the longest side. Now, and this is one of the very rare example, very unusual example where you get whole numbers. Now another example is this. It's these 3 numbers, 5, 12 and 13. Now you can check that if I write down 5 squared plus 12 squared, it will be equal to 13 squared. So again, it is a nice set of 3 whole numbers that actually satisfies the Pythagoras theorem. And these 2 sets of numbers, especially the 3, 4, 5, which is quite easy to remember, is definitely worth knowing because you see it quite often in mathematics and in physics questions. Right, next I'm going to look at the idea of congruent triangles. Now, congruent triangles means that 2 triangles are exactly the same in the shape and the size. So let's look at an example. I have 2 triangles like that. Now suppose that I have these sides here. Okay, I'm just going to put in some numbers. For example, like that. Now, if you look at these triangles, this triangle, you find that they have angles which are exactly the same, right? 60, 80, 40, 60, 80, 40, and they have this side which are the same. And if you actually draw this triangle and measure these two sides, this side and this side, you'll find that all the sides have the same length. So that's what I mean when I said two triangles that are exactly the same. They have exactly the same three angles and they have exactly the same three sides. The sides are equally long. So when you see two triangles like this, we describe them by saying that they are congruent triangles. So it's a special term for this relation. Now, congruent triangles are useful when you have two triangles that are, for example, that are rotated in different directions. So it's not very obvious that they are exactly the same. Or you may have cases where you don't know all the angles or all the sides, but it may be that if you just know one or two of the sides or the angles, you find that the two triangles are actually exactly the same. Okay, then you can use what you know about one triangle, you can use what you know about the angles and sides on the other triangle. So we'll look at one or two examples afterwards. But for now, let us just look at how you can tell whether two triangles are congruent. Now, obviously, if you are given, all the angles and the lengths of all the sides, then all you need to do is to just compare, just look at all the angles and all the sides, and if they're the same, then it's congruent. So that's easy. The problem comes for situations where you don't have all the information. So quite often you have cases where, examples where you don't know all the angles, maybe you just know one or two angles or even none, or you don't know all the sides, you might know one or two sides only. So in these cases, how can we tell, how can we decide whether, based on this information, whether there is enough angles or sides to imply, to tell us that the two triangles are congruent? So we'll look at some of these conditions and see when or what sort of information we need. Now, alright, so before I start, let's look at some ways of showing congruent triangles. So I'll start with the two triangles again. Now, to show that two angles are equal, for example, I would use an angle like that. Now, to show that another two angles are equal, I could use two of these little arcs. So that would mean, would suggest that those two angles are equal. And if I have a third angle is equal, then I can do that with 3 little arcs. So it's just a quick way to draw the picture showing you which are the angles that are equal. And likewise, we can do that for the sides. So if I want to show that those 2 sides are equal, that's a common way to do it, to put a little stroke across the side. And if I want to show that these other 2 sides are equal, but maybe not the same as that one, I can put 2 little strokes like that. So that means that these 2 sides are equal, but that this side can be different from that side. And in the same way, for the remaining sides, I can use 3 little strokes. Alright, so that's how we show that the angles and sides are the same. Alright, now next, let's look at the possible conditions. So suppose we have 2 triangles, like that. Alright, and suppose that we have these 2 triangles equal. I should say, suppose that we are told, we are given that those 2 triangles are equal. So just to make it more obvious, let me just put in some numbers and call that, say, 60 degrees. And suppose that those 2 angles are equal. So suppose it is 50 degrees. Okay, suppose that we have this information, and then suppose that we are given this side, that these 2 sides are equal. So let's say it's 10 centimeters. Okay, and suppose that these are all the information that we have. Can we say whether these 2 triangles are congruent? Right? That means that we only know 2 angles and 1 side are the same. So with this information, alright, we don't know all the sides, we don't know all the angles. So with this small amount of information, can we say whether the 2 triangles are exactly the same? Meaning that all the other sides are and the remaining angle are also equal. In this case, the answer is yes. As long as we know 2 of the angles and 1 side, that is enough information to say whether the triangles are to say that the triangles are congruent. So we can briefly describe this condition by saying, very simply, 2 angles, 1 side. Alright, so that is a condition, or the information we need to say whether 2 triangles are congruent. If you know that 2 of the angles in one triangle are the same as 2 of the angles in the other triangle, and that a corresponding side are the same, then the 2 triangles are congruent. So for example, it doesn't have to be this side. I can have those two sides same, or these two sides same. Alright? Let's look at another condition. Right. So suppose this time that we know one angle, let's say it's 70 degrees. We know that one of the angles are equal in the two. And suppose we know two sides. Say this is 10 cm, that's 10 cm, and that's 8 cm. Suppose these are all we have. Alright, we know two sides and one angle. Can we say that it is congruent? Well, in this case, yes. Again, we can. Alright, you can actually imagine one way to understand why this is enough to say that it is congruent is to think about whether with this information alone, is it enough information for you to construct, for you to draw the triangle? So you can imagine yourself taking a ruler and a protractor and a piece of paper and a pencil and trying to draw this triangle with a base of 1 cm. Okay, you will take a ruler and pencil and draw this line, measure out to 10 cm, and then you'll take a protractor to measure out 70 degrees, and along this line you will use your ruler to mark out the 8 cm length. Alright, once you've done that, you can see that you would then be able to draw the remaining line. Okay, so there's no problem with that, and it is the same for that case. Alright, but if using your ruler and compass and pencil, you find that when you try to draw the triangle, you don't have enough lengths or angles to do it, to complete the triangle, then there is not enough information to say that the triangles are congruent. So that's one simple way to understand it. So one more, right, let me write down this condition. So this is one angle and two sides. Okay, so that's the condition in this case. Right. Okay, now okay, the third condition is when we know that three of the sides, we know that all three sides are equal, but we don't know what the angles are. Okay, we just know that the three sides are equal. So in this case, they are also congruent, because you can imagine that if you try to draw the sides of the triangle, alright, with a ruler and pencil, you try to draw the length, then in this case you'll probably need a compass as well. We'll see more of this when we learn constructions later on. But there is enough information for you to actually draw this triangle. So this is one more condition, right? You know the three sides. So if you know the three sides, the triangles are congruent, exactly the same. Okay, now just as a counter example, we could imagine cases where there is not enough information to tell whether the triangles are congruent. So for example, instead of having the three sides, instead of knowing the three sides, okay, suppose that you're given the three angles only. You're given that the three angles are equal, but you don't know the sides. In that case, can you say whether the triangles are congruent? Well, the answer is no, because if you don't have the sides, if you have just the three angles, you can actually draw a big triangle and a small triangle, right? A big one and a small one, both having the same three angles, but with one with longer sides and so one that is bigger. So if you only know the three angles, the triangle can be either bigger or smaller. So that means that you cannot tell whether they are congruent if all you know are the three angles. That's not enough information. Okay, so number 4, there is one more. This is for right-angled triangle. So where one of the angles is 90 degrees. So in this case, you can tell whether they are congruent if you know the hypotenuse, if you know the longer side, and if you know one of the other side. Okay, if you know this information, then you can tell, right? Then you can tell whether they are congruent. Let's just have a look at one example to see how we could use this knowledge about congruent triangles. Suppose we have a question. Alright, suppose that this is 5 centimeters, this is 4, that is 4, that's 5. Okay, and suppose that this is 7 centimeters. So the question is, what is the length of this side? Well, since we have been talking about congruent triangle, right? Clearly, that's what I'm going to use. So the idea is to look at these two triangles and see if they are congruent. Right. So let's find out how many angles and how many sides are equal. Okay, the obvious side that are equal are the 5 centimeter here and the 5 centimeter there. So once one of the sides are equal, now at the other side that's equal is the 4 centimeters. So now we have 2 of the sides equal. Okay, the third side is unknown. We know that this is 7, but we don't know x, so we cannot say whether the two sides are equal. So the angles, are any of the angles equal? Yes, those two angles are equal. If you remember, those are the vertically opposite angles, so those angles are equal. Now therefore, the information we have here is two sides and one angle. If you remember, this is one of the conditions that the triangles are congruent. So therefore, those two triangles are congruent, right? That means that they are exactly the same, only that they are oriented in a different direction. And therefore, since they are exactly the same, the x there must also be 7 centimeters. Alright, since those two sides are the same as these two sides, the remaining side must also be the same. So therefore x is 7. Right? So what you see here is just one example of how you can use the idea of congruent triangles, right, to try to relate two triangles that are oriented in a different direction. So it is not obvious whether they are exactly the same, and also where you are only given a small, just some information. You don't know all the lengths, you don't know all the angles, right? You just know one or two of them, and then you have to try to decide whether the two triangles are congruent. And if you can, alright, if you can decide that they are congruent, then you can immediately find some of the sides that are unknown. Now next, I'm going to talk about similar triangles. Similar triangles are triangles that have all the angles equal, but for which the sides can be different, right? So these are called similar triangles. Now, perhaps in simple words, we may describe them by saying that they have the same shape but different size. So those are similar triangles. Now, what we learn about similar triangles is that although the sides are different, there is still there is a way we can relate the sides of the two triangles. Now, let me call these sides A, B, and C. Alright? Well, let me put in some numbers. Let's say this is 3 centimeters, this is 5, and that is 6. Alright. So let's say these are the lengths of the sides of this triangle. Now suppose that the length of this side is 6 centimeters. Okay? Then the length of that side must be 10 and of this side must be 12. Now in similar triangles, the ratios of the corresponding sides must be equal. If you look at these two sides, for example, 6:3, the ratio is 2:1, right? This is twice as big as that. So if and this side corresponds to this side, right? So if this side is two times bigger than this side, then that side must be 2 times bigger than this side, and that side must be 2 times bigger than that side. So the corresponding sides, so this side corresponds to this side, that side corresponds to that side, and this side corresponds to this side. So corresponding sides must have equal ratio, and that is the main idea about similar triangles. Alright, let's look at this example. In this example, we have, call that centimeters. We have one triangle here with angles of 50 and 70 degrees. That angle is unknown. One side is 30 centimeters and one side is called x. So we don't know x, it's an unknown. Right. Now in that other triangle, we have one angle is 50 degrees, the other angle is 60 degrees. One side is 15 centimeters, this side is 8 centimeters. Question is, what is x? Now, so is there enough information to find the answer? Right, since we're talking about similar triangles, that is what I'm going to use. But are these two triangles similar? Now, if you remember what I said about similar triangles, they have the property that all angles are equal and the ratios of corresponding sides are equal. So let's look at the angles. We know 50 and 70, we know 50 and 60. We don't actually know all the angles. So, but we could find the remaining angle, okay? Because we know that the sum of the angles, the sum of all three angles is 180 degrees. So therefore, I can find this by subtracting 50 and 70 from 180 degrees. And if I do that, I will get 60 degrees. Now, look at that angle. That is 60. 60 and 50. Right? 60 and 50. So therefore, likewise, we can calculate this angle and it will turn out to be 70. So now we have all the angles and we can see that the angles are indeed the same. Therefore, these are similar triangles. And we need to find the side of x the length of x. So let's try using this idea that the ratio of corresponding sides are equal. So the corresponding sides are these two, right? X corresponds to 8 and 30 corresponds to 15. So the ratio for these two sides is x over 8, right? And for these two sides, 30 over 15. So once we write this down, we see that we can solve it. This is just an equation in algebra. Okay, you can say multiply both sides by 8 and then you can find x. Now, quite often, there might also be a quick way to do such questions, especially at O-level exams. In this case, we can, just by looking at these two sides, we can already see what the ratio is. The ratio is 30 to 15. 30 is twice as big as 15. Okay, so this side is 2 times of this side. Therefore, x must be 2 times of this side. X must be 2 times 8. So x must be 2 times 8 is 16. So the answer is 16. Right, so what you see here is again that even if you don't know all the angles and all the sides of the triangle, you can make use of this idea of similar triangles, if they are similar, to find out some of the sides and some of the angles. So in that sense, it's like congruent triangles, alright, in that you can use whatever information you have to help you solve the problem. Okay, we are going to look at another property of similar triangles. Suppose I have 2 similar triangles. Alright. Now suppose that this base here is 2 centimeters and this one is 4 centimeters. Right, and that height is 1 centimeters. That height is 2 centimeters. Alright, we can see that if this side is twice of this side, the corresponding sides, so the height must also be twice of the height. Alright, so in fact this extends things a little bit. It doesn't have to be just the corresponding sides itself. It can be the corresponding any other parts of the triangle, like the heights. Now in this case we are going to look at the area. What can we say about areas of similar triangles. Right, now you can see that the length is 2 times of this. Now let's try and find the area. In this case, the area is half base times height, so half times 2 times 1, that is 1 cm squared. And in that case, the area is half times 4 times 2, that's 4 centimeter squared. Alright. So what you see here is that although the sides, this side is twice of this side, the area is not just twice of the area. The area is 4 times. Okay, and this happens because the ratio of the area is equal to the square of the ratio for the sides. Let me write this down. Okay, let me write this down using some symbols. Okay, so suppose that this side is A and this side is B, and suppose that this area is okay, I'll just call it big A, and this area is big B. Okay, so then the ratio B over A is related to the area big A over big B by this equation. Alright, this means that if I take the ratio of the sides, that's B over A, and if I take the ratios of the area, that's big A over big B, right, it should be B over A. Then the ratio of the area is the square of the ratio of the sides. Okay, so that means that if I know that this area is 1 centimeter squared, I can make use of this to find this area without having to do the calculation. Alright, because I know that this side is 2 times of this side. So 2 is the ratio, is 2 is the 1. So 2 squared is 4. Right? 2 squared, the square of the ratio is 2 squared, which is 4. So I can take 4 times the 1 to get the area without having to do a separate calculation for the area. Let me just look at one example to make this clearer. Right, suppose I have two triangles. Right, in this smaller triangle, I know two angles, 70 and 60 degrees, but I don't know the third angle, and I'm given that the area is 10 centimeters squared and the base is 4 centimeters. Now in this bigger triangle, I'm given that the two angles are 60 and 50 degrees, and I'm given that one side is 8 centimeters. The question is, what is the area of this triangle? Okay, since we are talking about similar triangles, let's check whether they are similar. We are given two of the angles, so we can find the third one. Just take 180 degrees minus those two, and that will give 50 degrees, which is the same as that. Okay, so likewise we can calculate this angle, and you'll find that it is 70 degrees. Now you can see that all three angles are equal, so therefore they are similar triangles, but they're not congruent because these sides are not equal. Okay, right, so if you look at the corresponding sides, you see that the ratio is 2:1. Alright, 8:4 is equal to 2:1. Let me just write that. 8/4 is equal to 2. Right, that's the ratio. So the question is, what is that area? Now I know that this area is 10 centimeters squared. Alright, so the formula that I wrote down just now says that if I take the ratio of the corresponding sides, meaning 8/4, that's the ratio of the corresponding sides, okay, and I square it, it must be equal to the ratio of the areas. So this area, unknown area, divided by 10. Okay, better use a symbol for that to make it simpler. So the area A divided by 10. So we can do that. It's just a simple algebraic equation, and you can find the answer for A. Now, there is a simpler way again. If you can just look at the two sides and say, right, that side is 2 times of that. Okay, so 2 is the ratio. Now, 2 squared is 4. Therefore, this area is 4 times of this area. And this area is 10. So therefore, this area is 4 times 10, which is 40 cm squared. Okay, so that's a quick way to do it. Of course, you can also do it using this equation. Let me just complete this. So 8/4 is 2 squared, it's A/10, which is 4. Then we multiply both sides by 10, and we get 4 times 10 is equal to A. 4 times 10 is 40, which is the same as what we got using the quick method. Okay, we'll stop here for this session. See you next time.